Hi, Assalamualaikum. Welcome back to my channel Physics Form 4 KSSM. Today I want to discuss on 3.1 Newton's Law of Universal Gravitation, Part 2. In my previous video, I've discussed about gravitational force acts between two objects, and then discuss about Newton's Law of Universal Gravitation, and then the formula is also derived based on that Newton's Law of Universal Gravitation. In this video, I want to discuss on the concept of force. There is centripetal force. Objects in motion tends to remain in motion at the same rate and in the same direction unless acted on by an outside force. I hope you still remember what is stated by Newton's first law. According to Newton's first law, this is that only a force that can cause an object to move out of a straight line path. In circular motion, the direction of body is continually changing at every instant. Therefore, a force must be acting. That force is called centripetal force since it acts towards the circle of the circular path. So according to Newton's first law, you still remember, or known as the law of inertia, if no external force acts an object, the object will continue motion in a straight line unless acted by an external force. Okay? So when object moves in a circle, the direction of the object keeps changing. Okay? So if keep changing means there is a force act on the object. So that when there is a force act on the object will follow a circle or circular path. So the force that acts, we call it centripetal force. So all circular motion requires a centripetal force. Otherwise, the body continues in a straight line path. So same happens to the object like satellite orbiting the Earth. So there is centripetal force act on the satellite. Okay, let's look at this situation. So we have this one, a straw, and inside here there's a string, okay, or a rope, and then hang a slotted weight here. End of this rope, we hang a cork. So what we do, just rotate the cork so that the cork rotating horizontally like this. When a body is rotated at certain uniform speed, with the string almost horizontal, the effect of gravitational force on the circular motion can be ignored. Thus, the speed is uniform. The direction of motion of the body keeps changing. So you can see this is horizontal motion. So gravitational force, which is acts downward, does not affect this type of motion. So the force is required to change direction of motion of the body. So the force that acts here, we call it centripetal force. Tension in the string is acting as centripetal force. So the same thing goes to this situation. Centripetal force is a force perpendicular to velocity of an object moving along a curved path. The centripetal force is directed towards center of curvature of path, meaning towards the center of the circle. So you can see all the tension force of the string directed towards the center. So the tension in the string now act as centripetal force. Same thing goes to the satellite that orbiting the Earth. The gravitational force that acts on satellites acts as centripetal force. Centripetal force in the motion of satellite and planets. When a body moves in a circle at uniform speed, the body is said to be in uniform circular motion, that is, satellite orbiting the Earth. An object in circular motion always experiences changes in the direction. To maintain circular motion, there must be force act on the object. Okay, so the changes in the direction in its motion, even though its speed is fixed. Speed is constant, but direction changing, thus velocity change. Okay. Satellites always experience gravitational force acting towards the center of the Earth. Gravitational force and satellite acts as centripetal force. According to Newton's second law, F equals to ma, All circular motion requires a centripetal force. Newton's second law of motion tells us that force equals to mass times acceleration, or F equals to ma. Therefore, centripetal force must produce an acceleration that we call centripetal acceleration. Since the force acts towards the center of circular path, acceleration must also towards the center. All circular motion is accelerated motion. The acceleration is always directed towards the center of the circle. The magnitude of centripetal force depends on these three factors. The first one is mass of the body, the linear speed, and the radius of the circle. Let's look at the formula used. Formula for centripetal force F equals to mv squared divided by r, where F is centripetal force, m is mass, v is linear speed, r is radius of circle. The linear speed shows how fast a body moves in a circular motion. So let's look at again this formula of Newton's second law of motion. By comparing the formula for force, F equals to ma, and formula for centripetal force, F equals to mv squared divided by r, centripetal force is equals to mv squared divided by r, so we obtain here ma equals to mv squared divided by r. So from here you can cancel m, thus you get centripetal acceleration equals to v squared divided by r. So actually for all objects orbiting or move in a circle, it will experience centripetal acceleration directed to the center of the circle. Okay, v is linear speed, r is radius of the orbit of satellite. Object launched with sufficiently high linear speed will follow trajectory that is circulating the Earth. The object will not return to the Earth. Example 1, figure 1117 shows a hammer throw athlete swinging an iron ball in an horizontal circle before releasing it. What is centripetal force act on the iron ball when the iron ball is moving at speed of 20 meters second to the power -1? So you can see here the radius of the circle, 1.8 meter, mass 7.2 kilogram. So we use the formula centripetal force F equals to mv squared divided by r. So you just substitute into the formula, so you will get mass 7.2, speed 20, and the radius r 1.8. Okay, so you just calculate, you get 1600 Newton. Second example, figure shows a weather satellite orbiting the Earth at height h 480 km, linear speed given, the radius of the Earth r also given. What is centripetal acceleration of the satellite? Height of satellite in meter 480,000 meter, linear speed, radius of the Earth. Then we use the formula here. Centripetal acceleration A equals to v squared divided by r. R is the distance between centers of the two objects, so it becomes radius of the Earth plus height of satellite. Okay, so you just add a r plus h. Okay, so you will get 7.62 times 10 to the power 3 squared divided by r. Okay, then we get 8.48 meters second to the power -2. So this is called centripetal acceleration of the satellite. Let's say we want to determine mass of planet. For example, mass of the Earth. By using Newton's universal law of gravitation that we discussed earlier, F equals to gmm divided by r squared. And the formula of centripetal force, F equals mv squared divided by r. The gravitational force that acts between two objects is equals to centripetal force. That's why we can write this way, gmm divided by r squared equals to mv squared divided by r. You can cancel the small m. So in this case, let's assume this situation, moon revolves the earth. Circumference of a circle with radius r is 2 pi r, meaning circumference of the radius of orbit. Circumference of the orbit for the moon revolves the earth. Time taken for one complete revolution is t. From the formula of speed equals to distance divided by time. If the satellite orbiting one complete orbit or one complete circle, the distance traveled is 2 pi r, and the time taken is period of revolution t. So we have v equals 2 pi r divided by t. From this formula, what we do, substitute v with 2 pi r divided by t. Just substitute here, 2 pi r divided by t. Okay, and then you do some cancellation. You can simplify to produce mass of the earth m as 4 pi square r cubed divided by gt squared. So using this formula, we can calculate what is mass of earth. Let's look at some example. For example, the first one, formula used to determine mass of earth or the sun. So we use m equals to 4 pi squared r cubed divided by gt squared. In order to determine or to calculate mass of the earth, we can assume case of moon revolve the earth. The small m is mass of the moon. Radius of the orbit or satellite of the moon, period of revolution. Data needed to calculate mass of the sun, we can consider the case of earth revolve the sun. So the small m become mass of the earth. Okay, the radius of the orbit of any planet, period of revolution of planet concerned. Okay, so it depends on the case that you discussed. For example, problem solving, period of revolution of moon around the earth. Given period in second, radius of the moon orbit r, calculate mass of the earth m. Okay, let's look at number 1. Mass of the earth, we use the formula 4 pi squared r cubed divided by gt squared. What is r here? R here is radius of orbit. Radius of orbit is also known as distance between centers of two objects. And the t here is period of revolution. So you just substitute in the formula 4 pi squared. This is the radius of orbits cubed. And this one is the universal constant g, capital G. And this one is period of revolution squared. Okay, use calculator to calculate. You will get mass of the earth is 5.97 times 10 to the power 24 kilogram. Second, earth revolve around the sun, period of 1 year. Radius of orbit is 1.5 times 10 power 11 meter. Calculate mass of sun. So in this case, the radius of orbit given, so just substitute here r, and then period of 1 year. Remember, period must be in second. 1 year, 365 days. You need to convert to second. 1 day, 24 hours. 1 hour, 60 minutes. 1 minute, 60 seconds. So you need to convert to second. Okay, and then you calculate carefully using calculator. So you will get the answer about 2 times 10 to the power 30 kilogram. So we have discussed about how to calculate mass of the earth and also how to calculate mass of the sun. So you can look at this situation. If you want to determine, for example, mass of the earth, you can discuss about moon revolve the earth, for example. Or if you want to discuss about mass or to calculate mass of sun, you can assume case of earth revolve the sun. And if you have all the values, then you can calculate the mass of planet also. Okay, that's all my video today. So I hope you can understand. I will continue in my next video, 3.2 Kepler's law. That's all. Bye.